Welcome to the third lesson in session 3 on identifying the foci of an ellipse. Now, an ellipse has two focus points, and as we discussed in the previous session, the plural of focus is foci. So there are two foci that we need to identify in an ellipse. Now, the foci will always lie between the center of the ellipse and the major axis vertices. And the distance from the center of the ellipse to the foci is defined by the value of c. And c can be found using the following formula. A squared minus b squared equals c squared. So here we're going to find the value of c given a couple of equations. Those equations should be familiar because we used them in the previous session, or the previous lesson. So in the first equation we have x squared over 25 plus y squared over 9 equal to 1. Now remember, it's important to identify which values of a and b. So the larger of the two denominators always takes the value of a. So in this case, the formula for c is going to set up as 25 minus 9 equals c squared. And as we simplify and solve, we end up with a value of c that is equal to 4. So what that tells us is that the foci of this ellipse lie 4 units away from the center along the major axis. Remember, the foci will always lie on the major axis, and c represents the distance from the center to the foci. In the second equation, we have x minus 1 squared over 4 plus y minus 3 squared over 36 equal to 1. So in this case, 36 takes the value of a. So my equation for c is going to read 36 minus 4 is equal to c squared, which simplifies to the value of c is equal to 4 root 2. So notice the value of c is not always going to be an integer value. So what this tells us is that the foci of the ellipse lie about 5.66 units away from the center along the major axis. So in this equation, I'm going to count up and down because I have a vertical major axis. So about 5.66 units up and down from my center will be my foci. So here are a couple of equations, and the graphs of those equations is already provided. But what we're going to do is find the value of c and identify the coordinates of the foci. So the first equation, we have x squared over 16 plus y squared over 25 equal to 1. So here we can see that the larger of the two values, 25, is located under my y variable. So this ellipse has a vertical major axis, and that can be identified in the graph as well. So we have a vertical major axis. So to find the value of c, I need to take 25 minus 16, which is a squared minus b squared, and set that equal to c squared. So when I simplify and solve, I get a value of c that is equal to 3. So remember, my foci now lie 3 units away from my center along the major axis. And my major axis is my vertical axis, so I'm counting up and down. So from my center, I'm going to count 3 units up and 3 units down, which adds 3 and subtracts 3 to the y value of the center. So in this case, I have a center at the origin, so my center is given as 0, 0. So my foci are going to lie at the coordinates 0, 3 and 0, negative 3. So I added 3 to the y value of the center, and I subtracted 3 to the y value of the center. In the next equation, I have the quantity of x minus 2 squared over 16 plus y plus 1 squared over 9 equal to c squared. So in this case, I have a horizontal major axis since 16 is greater than 9 and 16 is under my x variable. So a squared is given by 16 and b squared is given by 9. So to set up my equation for c, I take 16 minus 9 equal to c squared, simplify that, and the value of c is given as the square root of 7. So in this case, I need to add and subtract the square root of 7 to and from the x value of the center. So in this case, the center of the ellipse is given as the coordinate 2, negative 1. And since my foci lie along the major axis, I'm going to add the square root of 7 to the x value of the vertex, and I'm going to subtract the square root of 7 from the x value of the vertex. Doing that gives me foci values at 2 plus root 7, negative 1, and 2 minus root 7, negative 1. And those values take on about negative 0.646, negative 1, and about 4.646, negative 1. That wraps up our lesson. Good luck on the quiz, and please email us if you have any questions.